So you guys are in a group B, right? Part B. So we're meeting in class on Fridays. So let me explain how we're gonna do the part system this semester. So we're in part B over here. Okay. So we have a part B. Oh, by the way, it's my name, James Cho. This is my name. My email address, if you haven't got my email yet, it's just J. It's my first name J, and this is only my last name CHO. That might be the shortest last name you ever seen, but this is CHO at troy.edu. Okay. So this is my email. This is my name. So I'm going to be your instructor for this course this semester. Because of the COVID-19, we're gonna do some part A and B system over here. So we're in part B, okay? So we're gonna meet in class Fridays, okay? So technically speaking, this is our first in-class meeting this semester. We had another one with other groups on Wednesday, but in class-wise, we have a first meeting today. And then when you come to class to do the in-class attend, you're gonna come to in this room at this time next Friday. So it'll be next meeting. So you only need to come once per week, but here's some other thing I want to tell you, so please listen to me carefully, okay? So we have a part A students coming into Wednesdays, okay? You guys coming on the Fridays for in-class lecture. So whenever you do this, here's another thing I can tell you, that attendance is not required for this course. Meaning, yes, you can come to in-class lecture Fridays this semester, but it's not going to be a part of your total grade or anything. It's not required for your grade. But if you do come from next week, I'll give you a chance to get extra credit after every Friday lecture if you are in group B, okay? So at the end of each in-class lecture, we're going to have a very small activities, and then you have a chance to earn your extra points, extra credit every week, okay? But the thing is, we also have Mondays, right? Mondays open, and I'll have some here. So here's the thing. If you want to come to listen to me, like in class, you're going to attend the in-class lecture, you can also come to Monday here, okay? But I'm not going to lie, we have other student in group A. They also may want to come here. So you might have to compete, but by some good chance, you'll have a open spot, open chair, available chair. You can take a seat and you can listen to me in class. So possibly not just once. If you want to, you can come to Monday lecture. You can try to get a one spot in Monday lecture class. And also, if you just in case, if you really want to, if you wonder, if you just walk around the hallway for the class after your class, there might be some open spot on Wednesday as well, maybe one or two. If you want, if there's open spot, yes, you can also attend this one as well. But to be honest, it will be quite competitive anyway. So, but most likely Monday, maybe good chance too. So if you really want, if you prefer to learn chemistry in more like a personal real-time setting, you can do this. So maybe once it's absolutely available for sure, this is your actual regular in-class time. You can also shoot for those two if you see any open spot there. Okay, makes sense, right? So here's the thing. The last semester we had a part system, but as you know, some students may have some trouble or have some trouble, a hard time to understand the material by just watching the recording online video. So what I normally do is, as you can see, I'm recording my lecture. When I'm done with recording my lecture every week, I'm going to post my recorded online video on YouTube channel. So you'll see the YouTube channel name soon in Canvas today. But basically, if you just go to YouTube and just type Cam Troy, you can find me there. Okay, so either way, but you'll find the link on Canvas anyway soon today. So the reason why I'm saying still, if you don't want to, if you prefer to learn chemistry through the online platform, if it's a better way for it, that's totally fine. You don't have to come to class for your the grade, because all of the lecture I'm going to do in this class, Monday, Wednesday, Friday, will be uploading on YouTube channel. So you can always watch it. Even you attend in class lecture, sometimes you want to watch it again, or you want to have a better understanding of certain topics. You can definitely go to YouTube channel again, and you can double check, and you can listen to me again repeatedly over and over in the YouTube channel. Makes sense, right? Do you have any questions? So if you don't need any extra credit, and you want to stick to the online sort of a setting and learning process, you don't have to come, except the exam date that I put on the syllabus. You have to be there. You have to be here physically to take the written test. But other than that, you don't have to come. Okay, just come here for your Fridays, because you're in Group B. You may come. You can possibly come to the Monday if there's available open chair spots. Maybe if there's one or two spots open on Wednesdays, if you want to join us, you are welcome. But there won't be an extra credit twice per week, but just for the Group A people. So makes sense, right? Okay, so this is what we're gonna do. So if that is so I'm only doing this for you to have as many as a chance to attend the in-class in form of the in-class, in-person, real-time lecture. I think for some of you, it might be better for you to understand everything or most of the concept or topics in chemistry. So I want to move on to the grading grading system. So here's the thing. In this semester, in this course, you're going to have two midterm exams, okay? And each midterm exam will be worth 100 points. So that means you're going to have in total from the midterm exams 200 points. This is total points you can earn from doing two midterm exams this semester. Okay. So there will be one final exam. Okay. And there will be 200 points. Okay. 200 points. Okay. And then just one more thing we need to do in this course is online homework. Okay, online homework. So here's a good thing. Here's something that I'm gonna make a little bit of difference from the one we did, one I did last semester. Was only thing you need to have for this course is a textbook, either hard copy or online copy. It doesn't matter. Meaning you don't have to buy access code with it. Sometimes we do what we call mastering chemistry. It's an online homework system on a certain website. You can do it. But at this time, I'm gonna make a change. That is, just online homework will be done through Canvas. Okay. So you guys all know how to use Canvas by now, right? From the last semester. Okay. So if you go to Canvas, this is your Canvas homepage for this course maybe. If you look at the left side of your homepage, you will see certain numbers of a tab menu. Okay, so it's not open yet, but I'm going to open one of the tab menu for you maybe later this weekend. And it says the quiz. It says quizzes on the one of the tab menu on the left side of your browser Canvas homepage. If you click that one, you'll see the numbers of the Canvas quiz block. If you just click it, then you can take the quiz right away. Whenever you take the quiz, you only need to finish them before the deadline. I'm pretty sure I'll give you plenty of time to work on each Canvas quiz. But this is what we're gonna do for this semester. It will be about in total 100 points. So meaning you're going to have 500 points for your total grade to earn. Okay. So the reason why I'm doing the Canvas online homework quizzes maybe, instead of other online homework platform, is this one. Whenever you do the Canvas quiz, when I'll make announcement, I'll make announcement on the Canvas, or I'll tell you in the lecture. But we have a pod system, I can tell you everyone at the same time. So probably through the Canvas or email. Whenever you do the Canvas quiz, those questions you see on the quiz will be very similar to what you're going to see on the exams. So do not just try to earn those points by just doing the problems, but make sure you understand them and also try to remember the format or type of the questions. Then that will be the really good practice for your exam preparations. It makes sense, right? So only one downside of doing a separated website online platform is the question you see on the exam may be slightly different from what you already done in the homework, which I find it less practical. Okay, so in this way, you will have over the semester doing the quiz and try to solve the problem. Then you have a better understanding of the certain topics that I'm gonna put on the exam for the test. Okay, makes sense, right? Do you guys okay? Do you guys have any questions so far? We good? Okay. So if that is the case, we can earn about the 500 points over here. But here's another beauty of this system. I'm gonna tell you here. So I know some of you may take quite a time to understand certain topics in chemistry. I understand, it's just really somewhat time consuming. So for example, you had exam 1, you got 50 out of 100, for example. But you're getting better and better over time. So maybe exam 2, you got 80, okay? And then finally, at the end of semester, you're becoming really, really good at those chemical topics. So in the final exam, you got 190 out of 200, because it's in 200 scale, right? So if this is 190 out of 200, meaning you have a 95 percentile score on the final, right? Then I'll use this your percent score for the final exam to replace your lower midterm grade. So meaning you are going to have very last minute to do well in the course. So let's say you didn't do very good on 1 and 2, but if you do well on the final, you still have a chance to do well in this course, getting a really good letter grade. Okay? Yes, go ahead.
Is the final comprehensive?
Oh, yes. So that's a really good question, because the final exam is 200 points because it's comprehensive exam. Oh, actually. Yeah. So, and that is why final exam will be easier than regular midterm exams. So that is why I always keep this system in my whole life, and I saw lots of students did really well at the end of the semester, and it saved a lot of students. They did really well in the course. It really happened. Can you trust me? It's really so. There's no reason why you have to, feel bad about anything. So far, you have to get to the final exam, because nobody in here did really well because of this. I'm not kidding. It's really happened so many times. This is why I keep this exam policy in every course I've taught and going to teach this semester. Does it make sense? You're good? Okay, perfect. So this is what we're gonna do this semester. So this is quite of a something that we'll do over this whole semester. Okay. So today I'm gonna do only small portion of the first part of the general chemistry. But here's the thing. Whenever you think about the chemistry, I want to point out one thing before we move on to the class material. I assume you guys are in the science field, right? Science major, the nursing, or other biology or all of that. But I know that you are required. This is your requirements right? The chemistry. So I want to tell you why it is so important for you to understand the things in chemistry to do well in your other major field. So chemistry, this is the definition of chemistry. Chemistry is definitely, it's kind of a study that you want to understand how those things work at atomic level or molecular level. Okay. So meaning is, technically what it really means is you're going to try to understand what's really happening in a certain type of reactions or phenomena in the nature at a very, very small microscopic world, right? So all matters, all anything you see in the nature, in the universe, are made of certain chemical elements. And if you dip down to the very small world, you're going to see some atoms and molecules, which we're going to cover soon today. But if you have a really good understanding of what's really going on in the very small scale world, then you can finally understand how it really works in a more macro level, which means what? A lot of other type of engineering field, and also biomedical field and everything. So I'm actually a biochemist. I'm also, can you guys believe that I was once a undergraduate student too? Like I went to college, and can you guys guess how old I am? Like, just throw a number. It's okay. It's not a test.
30.
30? Oh, thank you so much. I'm about to be 36. So I went to college in 2003. Okay. So whenever I went to the college, I was actually majoring in bio. I was actually wanting to do something in a medicine field, like farm or then, and all sort of that. But obviously, the school required me to take the chemistry course, and I was like, oh, where's why you have to take the chemistry course? Now I do understand why it's so important, because this is really, really help you understand what really you're learning from any other advanced course from your freshman year. Okay, so trust me that if you do well in this course, you're going to have a very solid understanding of whatever your major field is. You're going to understand in a quite a better way. Okay, makes sense, right? So this is why within chemistry. So if you don't have any like hard time or any questions about any topic we're going to discuss this semester, just find me here. So my office is right across the hallway. It's in MSCX Q15 is right there, and one of the cubicle room is my office, and then I'm actually free like most of the time block on Thursdays. So Thursdays is the best time for me to communicate with you in person, obviously with the social distancing. Tuesday and Friday is not a good day. Okay, so you can try it. I might not be in the office most of the time. For Monday and Wednesday, you can definitely find me in the office after 2 p.m. And also maybe before 5 or 5:30 p.m. Okay, so this is maybe after 2 p.m. But the Thursday might be the best time. So you can also email me, but I find that the in-person communication in the office, obviously with the social distance, is more efficient way to discuss anything that you would like to discuss. Okay, so this is my office hour. So please make sure whenever we move on to each topic or another topic over time this semester, make sure you guys understand what it really means. Chemistry is one of the field of study you have to do for like a sequential learning, meaning if you don't understand the first one, there's almost no meaning if you move on to the next one, because those are highly related to each other. It's like you're not knowing the first one, trying to get to know about number two is almost miracle work that you need to do. So make sure you have a somewhat good understanding at least on each sub chapter as we go on. But if you do have a question, just let me know. I'll be right there. And also, you can try to watch my recording online video on YouTube channel over and over. But sometimes it's still hard to understand. Where any other questions, just let me know. Okay. So this is why we're doing chemistry. Okay? This is somewhat quite important field of study. We need to learn before you move on to your actual major field. You will become professionally expert on certain field. Okay, makes sense, right? Do you have any questions? We good? Okay, perfect. So okay, let's move on to the very first part of the chemistry. So obviously, I already told you what chemistry is. Whenever you think about anything in chemistry, we actually think about literally everything. So the first question in chemistry is, what is matter? What is matter? Okay, so this might be I'm not gonna lie, this might be the very good first question you see on the quiz and the exam. So what is matter here? Okay, so matter is simply any physical entity that has a mass and also occupying a space. Okay, so I can call this chalk as a matter because this has a certain mass and also it takes certain space in this area right now. So this is how we define something as matter that has mass. Is that something that shows you some extra mass, and also it takes certain part of your space. Then we can call this the matter here. So you don't have to know this, but any physics major here? Physics major, right? So if you go on to the maybe advanced physics, you're actually gonna think about this one again. Don't blame me for that one, actually. But in chemistry, this is good enough. Okay, so matter is this one. I mean, really. So anyway, so matter is this one. So one might be the one good example is not a matter. That is one of the good one is light. So light is the something that does not have a mass. Okay, it's hard to tell, it's occupy the space, but it doesn't have a mass. So the smallest particle, smallest portion of the light that we call is photon. You guys heard about photon? Photon is the smallest quantum of the light that does not have a mass. So whenever you learn about do you know who won the Nobel Prize 3 years ago? You haven't heard of Higgs field? So the light is the one that does not bother by the Higgs field, meaning it doesn't have a mass. Okay, so this might be the good example. But if you see anything that has mass occupying space, we can call that matter. Makes sense, right? You good? Okay, perfect. So let me move on. So whenever we have some matter, and if you look at that side of the room, you'll see the periodic table. Okay, that is the table we call periodic table, because each row you see on the periodic table is literally period. So first, second, third, and fourth, and so on. And you see the vertical column is what we call groups. So if you look at the periodic table, we're gonna get to that in detail later. Don't worry about it. If you look at the periodic table, you'll see numbers of the different chemical elements, right? So we need to know how each different chemical element is and how it works and everything. So before we get to there, the first we need to know for defining a certain chemical element is what is atom. What is atom, right? We need to know this one first. So atom is simply a smallest unit of, you can say chemical elements or something that has a unique, its own unique properties. Property simply means characteristics, like how special that atom is. Is it boiling point, or how it moves, how the stability and everything. So atom simply means. So I'm gonna explain this one real quick. So what it really means is this one. If you have a let me give you one example of lithium. Okay, I have a lithium over here. So if you have a lithium metal in your hand, you try to break them apart so many times. Okay, so you can have a smallest particle of the lithium metal will be maybe. Okay, so this is maybe your smallest lithium particle you can make by just dividing half and half and almost infinitely times. And then when you get to the smallest unit of lithium, and then if you try to break it, then it's not lithium anymore. Then that is atom. So it's literally smallest unit. So if it's smaller than what it is, it's not the lithium anymore. Meaning, when you split the lithium atom, it's not going to show you any lithium metal, any lithium atom property, right? If you put the lithium in the water, what happens? It explodes. But if you put the fragments of the one lithium atom, it will be just doing nothing in water, because this is lithium anymore. So atom, it means it's literally smallest unit of that specific chemical element, or that has unique properties. If you make it smaller than that, it loses everything. So one good analogy I normally use, I don't know if you guys like it or not. Do you guys like the water balloon fight when you're little? Actually, I had a big one with my younger brother. He kind of but anyway, so if you think about the water balloons, so think about this is a matter. Okay, this is think about the matter. So you just have a group of the water balloons here. So you can try to break them out, and eventually you get to only one water balloon, right? And then once you get to the one water balloon, if you try to divide it, it will pop, and it will become what? Just torn out rubber piece, not water balloon anymore. Makes sense, right? So the atom is just like one water balloon. That specific one that it's like a bouncy, like a water fluidity inside kind of characteristic. If you break it, it doesn't have it anymore. It's just a piece of the rubber and just a little bit of leftover water. So it's two different things. This is how we define atom. Okay, makes sense, right? Okay. So there's another thing I want you to know. Is the molecule. So whenever you see those molecules, or we can say molecule here, is any group or numbers of atoms, meaning obviously what? More than one. So 2 is fine. 2 or 3 or 4, but other than just 1, that numbers of the atoms are chemically bond to each other. So if they're bound to each other, so maybe one atom, so this is one hydrogen atom, there's another hydrogen atom comes, and they try to make a chemical bond, they'll become a molecule. This is how we write it, H2. This is a hydrogen gas molecule. So we know what atom is now, but those atoms now coming together make a certain chemical bonds. We're gonna learn about what type of bonds we're talking about later this semester. But whatever the chemical bond is, they make a bonds, it makes more than one atoms, making a groups or some like a sort of a cluster that we call molecule. Makes sense, right? So, for example, if you have a oxygen here, okay, oxygen here, and you actually going to have a chemical bond in these two, then there will be oxygen gas molecule, not atoms. Okay, but if you have a neon, which you can find on the very last column of the periodic table, they don't do any much of a chemical bond. There's certain exceptions, but normally they don't do any bonds. And this is just simply a atom, or just a neon element atom over there. But if it's more than one, okay, you can call that molecule. So for example, if I had give you water, it's a molecule or atom? It's a molecule for sure, right? It has more than one, which is two hydrogen. There are two hydrogens and one oxygen kind of bond together, making one water molecule. So you can call this water molecule. Yes. Okay. Makes sense, right? Okay. So here's one more thing I want to point out here. So now you know, oh, maybe if it is more than one, maybe one or two or three or four atoms make some type of a chemical bonds and become a bigger chunk of a physical entity. We call this a molecule. So this molecule is kind of a big, like a subset. But if you look at the molecules, if it is made of at least two different chemical elements, which is here, hydrogen and oxygen here, right? It's not H2, right? H2 means two same hydrogen atom made a bond, right? So that's H2. But if you look at the water, it made a bond between hydrogen. This is a hydrogen, two hydrogen making bond to the central oxygen over here. If you see the molecule, that shows you two different, more than one different chemical elements. You can also call this compound. So if that is the molecule that has more than two different molecules, then you can call that molecule 2, that's okay. But compound will be more specific name for it, right? So the compound is also one of a subset in a molecule. So anything that has more than one, you can call it molecule. But you also see the more than one chemical elements in that molecule, you can call that compounds. Make sense, right? Okay, so if I give you this is a methane. It's a CH4, meaning one carbon making chemical bonds to the four different, same elements, but four hydrogen around it. So this will be molecule for sure, right? This is a molecule, but also compound. Makes sense, right? So maybe if I say, how about nitrogen gas molecule? Is it compound? No, perfect. Because those are the bond made from the same elements, which is nitrogen and nitrogen. So this one is just a molecule, but not a compound. Makes sense, right? Okay. Can I move on? Okay. All right, so if that is the case, how about the three different phases of the matter? Okay, so meaning, I think you guys all know this one, but the first one is a solid. Okay. The next one is a liquid one, liquid. The last one is gas. Okay. So sometimes you may heard some plasma. You don't have to worry about, because we want to know about the matters in those are three main phases, but not the plasmic, which can be only found in the limited space in the universe. So just worry about those three: solid, liquid, and gas. Okay. So if you want to know the definition of those, you need to just think about the first you need to think about the order. Okay. What I mean by order is if you go from like the left to the right, your order of the matter will be lower. Meaning, if you look at the solid one, they're all going to show you some uniform pattern of arrangement of atom or molecules. Meaning, if you look at anything that in solid phase, the solid status, you see the atom or molecule are showing very same pattern of the arrangement on the space. So if you see those four are making this type of simple cubic structure, you can see other side of the matter also making the same structure all over the matter if it's in solid phase. So the best example of this one is crystal. So if you look at the crystal, they all have a specific pattern. There's a specific way to arrange those the atoms and molecules in a space. And also another thing is the distance between those among the atoms and molecules is small, very small. So they're going to show you quite of a good stability. So the distance between those two are quite small, and the ones in the solid phase. Okay, but if you look at the liquid, now you're losing all the uniformity in the arrangements. So meaning they're going to have a not uniform pattern of the arrangements, but they have a more freedom to move around the space freely. Maybe distance between these two will be larger, slightly larger, will be huge differently larger. Will be the distance normally become larger among the molecules or atoms in the liquid phase. Okay, so you see the distance kind of getting bigger and bigger in here, and this is sort of the reason why they have more freedom to move around in the space. That is why if you look at something in the liquid phase, it doesn't have a specific shape or anything. It only goes with the shape of the container, right? Because it moves more freely than the ones in the solid phase. Okay. So the last one is the gas. This is the one that has the longest distance between atoms and molecule. Okay, and obviously it means this will show you the maximum volume of your matter and gas phase. Okay, because they keep this huge distance from each different atoms and molecule to each other. So they will actually occupy really big space. So if you think about the certain, if you think of the nitrogen, liquid nitrogen here, if they being vaporized, the volume of the nitrogen in gas phase will be a lot bigger than ones in the liquid. It says because they tend to have long distance among the atoms and molecules. And obviously, this will all experience the even higher freedom that it has in the liquid phase, because there's such amount of the. You don't have to know this one for now, but those are the ones that we call this intermolecular force, meaning if you have a matters kind of coming close to the proximate distance, they're going to interact each other. meaning they're going to have a certain amount of strong force to holding them each other. But that is almost impossible in a gas. That's why they kind of put a lot of distance and making a really huge volume in the space. And now you wonder why. You guys wonder why? So the difference between solid one, liquid one, and gas is mainly, normally, the distance and how much freedom it has when it moves around the space, which is the one in the solid phase, barely none. But able two is a little bit more, and gas, they will experience a lot of freedom to move around in the space, occupying bigger and bigger volume. So the reason why they are in three different phases and they have a different type of property over here because of the kinetic energy. So kinetic energy is the energy of something that is moving. So when it's moved around the space, while it's moving, they can have a certain amount of energy while it's moving. So that makes that molecule or compounds are moving in the space. So if they don't have a kinetic energy, they cannot move much. Whenever they have a very high in kinetic energy, they can actually move. So how they get the kinetic energy most of the time is from heat. So heat energy is kind of special in here. When you try to boil the water, once the water molecule is in the liquid phase, but heat energy comes into the water molecules, and they try to give a lot of energy in kinetic energy. Meaning what? They're going to have a much more energy to move around than before. So that is why they are able to put a lot of distance among them, overcoming the interaction among them. So that is why they can be vaporized and becoming in the gas phase and it takes the bigger volume. Okay, so these two is I'm going to talk about some next week too. Okay, so this is three different phases of matter. Does it make sense? We good? Okay, perfect. I'm going to go over just one more thing, and I'll finish up today. Okay. What I normally do is I try to repeat what I do in every lecture. Even I move on to the new topics to help you remind you of certain things to the previous ones so we can understand new topics better. So anyway, so the only one more thing is what we call chemical change and physical change. Okay, so there's a reason why I explained this three different phases of matter first than this one, because the chemical change is the one that shows the change in identity of reactants. So reactants simply means before the matter before the reactions. So something never happened yet, then your initial product, your initial sample is the reactants. So that's how we named it reactants. That's the things that going to have reactions. So we call them reactants. The initial matter before any reactions. The physical change that only change the phase of matter. So a good example of this one would be you boiling water. So H2O is water, right? We put the small subscribe parenthesis, we put the L because it's a liquid. And then if you just do the chemical change, with a lot of heat over here. And now they're going to be in still H2O, but in gas phase. So I'm going to put the Z on the small parenthesis subscribe under H2O. Okay, because a lot of heat goes in. Like I said, they become a kinetic energy. They can have a more freedom to move. So they can be once in the liquid phase, but with this lot of heat during the physical change, they're going to have different phases now. So the key point here is that water is still water. Only thing that changed was what? Phase. Once it's liquid, once it's gas. So then we call this physical change. So this is a chalk, right? If you break into half, it's still chalk. That's physical change. I use my physical force to break it, but it's still chalk, the same thing. It's just smaller. The chemical change is what it really changed the identity of the reactants. Okay. Here. Okay. So when you try to make the combination reaction with the hydrogen gas molecule and oxygen gas molecule, they can make the water. So now you can see hydrogen and oxygen are different from water. It's chemically different. So after chemical reaction or chemical change, you're going to see a different molecule. But in a physical change, it's still same, but only changing the phases of matter. Pretty simple, right? Okay. I'm gonna start.